Hi everyone, welcome back to the workshop, and I'd like to say it was repair time again, but it's not, I'm afraid. And although I do have a repair down on the workbench here, I'm actually in software mode at the moment. For the past 3 or so weeks, I've just had my hands full with 3 different software projects, and I'll just talk a little bit about each one. But first of all, let's have a look at the repair that is on the workbench that I'm currently recording a video for. And this is my own Agilent power supply, the one that usually sits up on the workbench here. It's the 0 to 8 volt, 0 to 20 volt, 20 amp, 10 amp power supply, and it developed an intermittent fault about a month ago, and it slowly got worse, and it's down on the workbench here in a million bits, and I'm currently recording a video. But more on this one later on, hopefully, once I get to the bottom of the problem. But what about that 3 software projects? Well, one of them's professional and the other 2 are home projects. The professional one is an Access database, a Microsoft Access database I developed a couple of years ago, and I was asked to make some modifications to that, which I have been doing in the background. Can't show you any screenshots or anything like that, but the other 2, the home project ones, I can certainly talk about. So let me go over to my PC and I'll show you what I've been doing. The first of these home apps was WindGPIB. I've actually been doing some modifications to it that took quite a wee while to implement, and if you don't know about WindGPIB, it's basically a free Windows app that I've written that can connect to various test instruments, etc. via the GPIB port, whether it's Ethernet, USB, or the traditional GPIB port on the back of such devices. And it's a dual channel, so you've got IO device 1, IO device 2, and the modifications I was making to WindGPIB were to actually implement the ProLogic serial and ProLogic Ethernet compatibility. There's various different types of GPIB modules and connectivity for connecting to these test instruments, and I'm obviously implemented VISA and a few others including serial, but I'd never ever gotten round to implementing ProLogic. These yellow GPIB adapters. I'll put one on screen now, and another that I got off of AliExpress. So I got a hand actually to implement this from somebody on the EEV blog forums going by the name of TPPC. As you can see here, he actually wrote the USB version of it, the serial version, and I went and adapted that for the Ethernet version. And as you can see, I've got my 3457A multimeter here connected to WindGPIB, and I'm currently logging 1 volt. I've got my PDVS2 Mini connected to the 3457A. And if you don't know about WindGPIB, it's got a lot of different options for various instruments, etc. And on the 3457A, I've actually written some code to enable the 7th digit. The 3457A actually has a 7th digit. It's a 6.5 digit multimeter, but via GPIB only, you can actually turn on a 7th digit compatibility. And here you can see it here, that last digit there is the 7th digit. So I'm logging a 1 volt signal. And going along the tabs here at the top, just to show you WindGPIB, you've got basically the main screen here showing the 2 IO devices here where you can set things up, set some pre-run commands, at-run commands, etc., and kick off the login, etc. And you can also, you've got a command line interface here if you just want to send GPIB commands to your device at a sort of command line level. You can do that here. You've got some large digits here for like a device meters view. If the screen on your PC is across the other side of your workshop, some people found it real handy to have this sort of mode. You've also got the ability to interface temperature and a humidity sensor into WindGPIB. So at the moment I have my workshop temperature and humidity sensor. You can see them running there, and there is some compatibility with various different types, mainly the Dog Ratian temperature probes, but also Adafruit and also a user-defined protocol that you can actually set up here. You can also log data to the screen, as you can see here, and you can also log it to a CSV file here. There's also a live chart, as you can see here. It's currently been running for about 56 minutes, and it's basically just logging that 1 volt sample coming in. And the red trace there is actually the temperature sensor as well. You've also got a playback chart. This is for analysing and displaying graphs from your CSV file here. If I just pull one up quickly, let's just pick that one there, not sure what it is. There we go. I've just read in a CSV file here, and you can zoom in and out on that CSV file here, and you've got various options for setting the scale of your temperature and humidity sensor. If I just turn them on as well, you can see temperature and humidity there. There's also some options up here for turning on ppm, deviation and tempco calculation. So fourth trace on the graph in this particular setup here. So if I just enable that, you can see I'm displaying ppm deviation around a medium value, which is this voltage here, but I can take it from the CSV if I want to, which will be the very, very first voltage coming in, and there it is there. You've also got the ability to extract RAM calibration data and settings data from a 3458A. Most 3458A users will be aware of this. The worst scenario with a 3458A is actually losing your calibration. It's going to cost you over £1,000 to get it recalibrated at Keysight. But there is a way to extract the calibration data via GPIB and save it to a file for later putting back onto the device. And you can do a similar thing with the 3457A. The next tab is the 3245A calibration. That's HP Universal Source. Found a way of implementing calibration of the 3245A in conjunction with the 3458A. You don't actually need any other test gear to do it. You can connect them both together, hit a button here, and it'll go way off and calibrate the 3245A against the 3458A. And the last tab here is basically the PDVS2 Mini calibration. I used to use this one all the time when I was in production of the PDVS2 Minis, and that was just a way to automate the calibration and produce the actual calibration certificate all automatically. And the last tab is basically an About tab where you can donate to me via PayPal. Again, this is a free app. It's open source, kind of, in a way that I actually do publish the actual source code to anyone that wants it. So that's the mods I've made to WindGPIB, mainly the ProLogic adapter, implementing those protocols there. But as ever with my own software, I never tweak one thing. I would have taken the opportunity to go away off and actually make some other mods to other parts of the software. Now you can actually access the EEV blog forum where there's a forum thread. I'll link it down below. There's a 35-page forum thread all about WindGPIB, full of screenshots, etc. And any updates I make to the software, I post them here. And if you've got any requests for any future mods, then you can also do so via the forum. Okay, so the next piece of software I've been working on is actually the energy control app that I wrote, which originally was designed to look after the temperature in the workshop here. I've got an aircon here in the workshop, and when I first installed the aircon, using its own control, basically a remote control that came with it, it had a large hysteresis of about 4 degrees, something like that, probably down to the size of the workshop being quite small. It was too easy for it to overshoot and undershoot when it was controlling the temperature. So when I was in production with the PDVS2 Minis and I needed a really stable workshop temperature, it was just no go. So I ended up writing my own software and basically disabled the aircon built-in control mechanism and implemented my own via the Wi-Fi connection to the aircon itself. And as you can see here, I've got the controls for it here for the cooler, the fan, and the heat mode. And I've even got a timer where I can set it to come on in the morning before I get out to the workshop, that sort of thing. And up the top here is basically just the ports used, etc., the IP addresses, etc. for that. Now, when I had that app running on my web server 24/7, it's a PC that I have in my server rack that's running 24/7, so it made sense to install it in there. And right now I'm actually remote desktoped into the server, and that's how we can see the app here on the remote desktop connection. And so it didn't stop there. I added functionality for monitoring my solar panels. As you can see here, we're making about 1,700 watts right now from the solar panels in the roof of the house. And along with that, some various temperatures and etc. to do with the inverter in the inverter battery room that I've got. And after that, I implemented a smart meter of my own in the house, and as you can see here, it's measuring basically the import power, export, and the load in the house and the line voltage and frequency there. Now that's been running nicely for the past 2 or 3 years, no problem whatsoever. But in November, I actually added a battery to the house and wanted to implement that onto the app as well. And as you can see here, I've got exactly that. You can see the battery capacity right now is at 90%. It's currently charging because there's solar activity at the moment via the panels, and it's charging at about 968 watts into the inverter, into the batteries there. Now, for the most part, you could probably stop there because I'm monitoring the batteries, I'm monitoring the solar panels, I'm monitoring the energy in and out of the house. But I actually thought, well, we can go a step further, because on the tariff that I'm on through Octopus here in the UK, there's actually different rates depending on the time of day. Now, if you think about it, in the middle of the winter, etc., when there's not much solar activity, you're not going to be able to charge the batteries, not very much anyway, from the solar panels on the roof of the house. So you have to rely on importing power from the grid to actually charge the batteries. And because Octopus provide different rates for that import power depending on the time of day, I wanted to make use of the 2 a.m. to 5 a.m. Tariff window, which is half the cost of the normal window for the rest of the day. So it makes sense to charge the batteries between 2 a.m. and 5 a.m. So a lot of my friends have the exact same system, and they look at the weather the night before and decide whether to enable or disable that nighttime charging. And they have to do that on a daily basis. And I thought there must be an easier way of doing this. So I found out how to connect to the actual Solus inverter, because they actually have an API, an application programming interface. So Solus actually provide a whole load of tools, protocols and definitions that allow you through your own software to connect to the inverter and make any changes. So I found out how to do that, and over the right hand side here you can see that I can change manually the actual 2 a.m. to 5 a.m. timing. I can change it for 1 hour, I can change it to 30 minutes. I can basically set it up how I want and just press the button and it'll send that timings into the inverter. That's to save logging in through the app on your phone or on the desktop, which is a bit of a rigmarole because you have to log in, put in passwords every single time and dig through the links in it to eventually get to the timing page, which is buried away. So this made it a lot easier. But I went a step further than that again, and that was where I actually connect to an external website called Meteosource, where they publish and forecast irradiance and cloud cover data for tomorrow and the day after, etc. So I've got my app here at just before midnight every day, going to Meteosource via their API, grabbing the next day's irradiance values, cloud cover values, and then I do some calculations, bring those two values together to come up with a hybrid irradiance cloud value. And you can see that 973 was today's forecast, because this was run at just before midnight last night. It came up with a figure of 973. I've then got a rules table in the software. Down here, as you can see, you look up 973, that's second one down, and that would set a charge time of between 2 a.m. and 4:30 a.m. And what that does, that will allow the batteries basically to last the entire next day. And the good thing about this is it's totally hands-free. It automatically goes off at just before midnight, grabs values, runs the calculation, comes up with a number, and then applies it against the rules table, and then automatically sends those new timing values to the Solus battery inverter. And then down here I've got three graphs. The first one's the workshop temperature, the next one's the solar activity, that's live data scrolling from the right to the left. The graph is either 12 or 24 hours long depending on the setting up here. And then the battery capacity. I started the app at midday today, again after making some more mods. As you can see, it started to drop and then it started to climb again, probably when the sun started to come out again. But come 4 or 5 o'clock in the afternoon today, the sun will sort of disappear, the radiance values will be low, and the batteries will start discharging into the house rather than charging as they are now. And that should last no problem at all. It's a 10 kilowatt hour battery through basically to 2 a.m. again. So I'm still tweaking the software here, trying to work out what the numbers should be in the rule set for the timings here. I think at the moment I'm a little bit out on the table here, because I think the 973, which was giving me 2.5 hours of charge time from the grid, I don't think I needed all of that. It probably could have been 1.5 hours. So I'll need to tweak those values a little bit, and just to get it optimized perfectly. In addition, the app also takes into consideration the month of the year for the sunrise and sunset times in order to grab the correct irradiance data from the Meteosource website. So that's it. That's the 3 software projects I've been working on at the moment. Nearing the finish line now, just maybe a few more days to go, and then I can get back on with this HP power supply. So thanks for watching, and remember, you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.